This is section 10.5a for Algebra 1B, and we are solving radical equations. And we're going to start off by filling in this little bracket or this little box here that says steps to solving. Step 1, we're going to isolate the square root. Isolate the square root. So this example we have down here, step 1 is already done for us. The square root is on one side of the equation, and on the other side of the equal sign is stuff that doesn't have a square root. Sometimes it's just going to be a number. Sometimes it might be another square root, and sometimes it might be another expression as well, and we'll look at those on section 10.5b. But step number 1 is to isolate the square root. Step number 2, we don't want the square root anymore, so we are going to square both sides of the equation. We'll square the left, we'll square the right to get that square root sign out of there. Step number 3, I'm just going to say do the algebra. Add, subtract, multiply, divide, do whatever you need to do so that you can solve the equation for x. Step number 4, and we don't always do this in math, but we probably should. We absolutely have to do it here. Check the solution. And we're going to see that sometimes we do everything correct in these problems. We don't do anything wrong. We get an answer, but the answer just doesn't work. When that happens, that's called an extraneous solution. It's something that we did that worked with the way we solved it. However, it didn't work with the original equation that we had. And if that's the case, we can't include it as a real solution then. All right, let's get into this first example. So step 1, isolate the square root. That's done. There's only square root on one side. There's no square roots on the other side. Step number 2 is we're going to multiply both sides by themselves, or we're going to square both sides. The right side squaring that is very easy. 7 times 7, that's 49. The left side, when you take a square root times that same square root, the square root sign should drop off. Recall, if we had something like the square root of 131 times the square root of 131, it comes out equal to a plain old regular 131. So that's the benefit of squaring this side, is when you take this times itself, it becomes plain old regular 2x plus 5. The next step is to solve the algebra, so I would subtract 5 from both sides. 2x equals 44, great. Divide both sides by 2, still doing the algebra that I know how to do, and I get x equals 22. Now, normally at this point, I would box my answer, say, great, I'm correct, it's time to move on, but you have to check your answers for these problems because, again, sometimes you'll do everything correct and it just doesn't work. So I'll go back to the original. It says 2x plus 5. Question mark, when we plug that in, does it equal 7? So when I plug in this 22, where that x was at, does it make the equation work? So 2 times 22 is 44. 44 plus 5 is 49. Then I would be taking the square root of 49. Does that equal 7? Yes, it does. So my answer is, in fact, correct. You have to check that at the very end. Example 2 looks a lot like the first problem. The numbers are different, but it's all set up that the square root is by itself equal to something else. So like the last one, because it's set up that way, we're going to square both sides. When you square the left, you get plain old x plus 1. When you square the right, you get 4. There's only one more step to solve this one algebraically, and that's to subtract 1 from both sides. So then we get x equals 3. Remember, now we're going to check this. The original problem that I have in black ink up here says the square root of x plus 1 is equal to negative 2. I think x should be equal to 3, so if I plug a 3 in for where that x was at, I'm evaluating. 3 plus 1 is 4. The square root of 4 is 2. However, 2 does not equal negative 2. So here's one of those problems where I did everything correct. I got a potential solution. However, it didn't work. We would call this one extraneous. So then I'm going to say that if that one doesn't work, then nothing's going to work. So there is no solution. There's no real solution. There's no number that I can plug in for x to make this problem work. I'm not going to erase my work. I'm going to show everything. I'm going to even make sure that this potential answer could be seen, but I am going to cross it off and say there is no solution because the one and only potential one didn't actually even work. Here's example 3. And in this one, we have a little bit more to do, and that's because the square root isn't isolated. Notice that square root sign ends right here. It's not a big long one going over the +2. It's only over the square root of x. So step number 1 in this problem is to subtract 2 from both sides. That gives us square root of x is equal to 4. Good news, now the square root is isolated, and that's what we want to have happen. So at this point, you're going to square both sides, take 4 times itself. The square root of x times itself is x, so I got x equals 16. A quick check. Plug 16 in for x is the square root of 16 plus 2 question mark equal to 6. I took my equation, I wrote it out, I plugged 16 where the x was at. The square root of 16 is 4. 4 plus 2 equals 6. Yes, it worked, so x equals 16 is the solution. Example 4. Once again, we still need to isolate this x, so add 1 to both sides. Plus 1, so this is equal to 5. Next step, you're going to square both sides. Square the left, we get x over 8. Square the right, we get 25. And we still need to get this x by itself, so how about you multiply by 8 to get that out of the denominator? We'll multiply the other side by 8 as well. So I believe then x equals 200. 25 times 8 is 200. Here's the check. Square root of x, I think that's 200, divided by 8. Again, I'm taking this original equation. So square root of 200 over 8 minus 1, question mark, does that equal 4? Well, 25 times 8 was 200, so 200 divided by 8 must be 25. 200 divided by 8 is 25. The square root of 25 is 5. Minus this 1, does that equal 4? Yes, it does. So x equals 200 is the correct answer. Example 5 is another one where we have to do step number 1, where we have to isolate the square root. And I notice that this time the -3 is multiplied by that square root. And so I have to isolate the square root by getting rid of this. I don't add 3 to both sides because it's not -3 plus that. Instead, we're going to divide both sides by -3. That makes those two cancel out. Dividing by -3 is how we undo this -3 that was multiplied by that. So it's the square root of x minus 5 equals 9. Now we're going to square both sides. Square the left, we get x minus 5. Square the right, we get 81. Next step, add 5 to both sides. Plus 5, plus 5. So x equals 86. Feeling pretty good about that. Let's see if I check my answer over here. Here's my original equation. So it's -3 square root of x, which I think is 86, minus 5, question mark, does that equal -27? And when you're checking these, you should run into some familiar problems as you're going through this check. What I mean by that is 86 minus 5 is 81, and I had an 81 earlier, right? So 86 minus 5 is 81. The square root of 81 is 9. There's the 9 I had earlier. So 86 minus 5 is 81. Square root of 81 is 9. 9 times the -3 on the outside is -27, which does equal -27. That's great. So x equals 86 is the correct answer. Example 6, and we're looking at our last one here. Step number 1 says we're supposed to isolate the square root. And this time there's two square roots. There's one on the left, there's one on the right. And which one are you supposed to isolate? Well, the good news is there's nothing else outside of those square root signs. And we'll eventually see some problems where that is going to happen, and that makes it a little bit more difficult. But step number 1 in this one is just going to be to square both sides right off the bat. When you square the left, you get 3x minus 5. When you square the right, you get 2x plus 4. Now we go through our algebra process. Minus 2x plus 5. These cancel out. These cancel out. The left side is x. The right side is 9. Next, go ahead and check that. X minus 5 equals question mark 2 times 9 plus 4. All right, here's the equation. I'm plugging x in anywhere, or 9 in anywhere I see an x. 3 times 9 is 27. 27 minus 5 is 22. So it's the square root of 22. That's some decimal. I don't know the exact value. We'll leave like that for a second. On the right, 2 times 9 is 18. 18 plus 4 is also square root of 22. So even though I don't know what the square root of 22 is equal to, it is the same thing on both sides, which means x equals 9 would be our correct answer.